Hello everyone. I'm going to show you how to complete the milestone 2, the classification. Okay, so let's have a look on the tiny URL, the lab guides. Yeah, okay, so okay, here you go. The milestone 2 is basically not the lab fast, but the milestone. Yeah, classification model for learning disability prediction. Yeah, so actually, for understanding these experiments better, then we need to understand about the data set that we are using. Yeah, like in the first milestone, we learn about the sleep hours prediction from the student performance. Okay, so I'm trying to get the information about this student performance data, so at least we understand what is the column in the data set. Okay, so I search student performance factors data set column explanation. This one is available in the Kaggle. Yeah. Okay, so this is explanation. Dataset contains comprehensive information on the 2,392 high school students, detailing their demographics, study habits, parental information, extracurricular activity, academic performance. Yeah, the target variable is a grade class. Classification classify students' grade into distinct category. Yeah, okay. So this is student information. Okay. Yep. So we have the gender, high school, study habits, yeah, parental. Is this the same data that we have? Let's have a look on the. We're going to download this first, yeah. So in the tiny URL, okay, copy this. Then we log on first, yeah, as usual, with this username and the password. Okay. Okay, we download the dataset. Maybe the data is different because our is 6,000 something. Eh? Okay, open the file, extract all here. Okay, let's see. It could be different data set. Okay, here you go. So this is the data, like our study. I think the column is quite straightforward and self-explained. And then after that, the attendance. After that, the parental involvement, access to the resources, extracurricular, yeah, sleep hours, preview score. Okay. Then after that, the motivation. Yeah. Okay, yeah, I think the data maybe not the same. Yeah, never mind. So we just use this one. So one of the column is this learning disability. Yeah, no, and then after that, yes, no. Yeah. So this is two class categorical column that no or yes. So let's interpret what is the meaning of the learning disability. So learning disability is whether this person has a learning problem, disability or not. Yeah. So if yes, then yeah, the problem is there. Yeah. So it has. And then we would like to see now later. Yeah. In the so mostly is no. Yeah. Mostly is no. And then if you capture this into the table, yeah, so make it table data after that call it okay, wait because this one is CSV home after that okay, one moment. Okay, never mind, later we will do it, we will do this in the Azure. Yeah, but like David last time mentioned, there are some incomplete data, yeah, on the last two column. Yeah, the last two column is the study extracurricular and then the study physical interaction. So maybe these two not really important, yeah, because you can see after the row number, yeah, here you go. Yeah, after the row 6000, then this empty, yeah, no value, and then this along the way until the last row, which is 14,000. So 8,000 from the 14,000 are empty. Yeah, so maybe we need to do something with this. Yeah, like we may want to uh, exclude this column. Yeah, we will play with this later. Yeah. Then some is empty. Yeah. Okay. So yes, yes, no. Yeah. Okay. Okay. So we will do the quick overview about this column later after we import. Yeah. So the step in the milestone one is very much similar like you have done before. Create the pipeline, then after that train the class. So in this exam, in this milestone one, we try to play more, yeah, play more with understanding the data more, and then also the uh, play around with this data. Yeah, okay. So yeah, I will not continue from in the Kaggle because I think we are looking at the different data set. Yeah, but let's look directly to this student performance. So we already downloaded and extracted. Okay, so as usual, I should do this earlier to create the resource group and the machine learning workspace. So this something you have done before many times. Yeah, I will not need to explain more detail about that. Yeah, so machine learning workspace. Okay, so close. After that, the Azure machine learning workspace. Then, yep, this one. Create. Yeah, so create new. Then the milestone2, yeah, RG. Click OK. After that, the name is MLW machine learning workspace mouse2. Yeah. The name is not consistent, but this is just any name. Yeah. Okay. Then after that, review and create. We don't change anything particular for this. Just use the default. Okay. After that, create. Just wait more. Okay. Create. Yeah. Create. After this, then we open the machine learning workspace. After that, create the compute instance. After that, import the data. Okay, let's back to the data. During the regressions, we have learned about the how to predict the sleeping hours, and then we found out that the data is actually not good for predicting the sleeping hours, because we got the model, but the coefficient determination is minus close to 0. Yeah. But when we change the regression to predict the exam score, then we got the better result. Yeah. So this data, the column, yeah, quite okay to predict the exam score. What does that mean? That meaning that by understanding how many hours students study per week, yeah, then after that the attendance, normally the score is not bad. Yeah. But if the attendance low, then less study, then maybe the result is not very good. Yeah. So something like that. Yeah. So yeah, we're going to classify, create the classification, binary classification, yeah, with this column as a target. Yeah, learning disability. So by having information about the other column, like how many hours students study, the attendance, the parental involvement, and so on, then we're going to predict, yeah, whether this this student has the learning disability, yes or no. Yeah, that's the outcome of this classification. Yeah. Okay, let's go back to still ongoing. Yeah. So we're going to use the two-class neural network and boosted decision tree as a two-class classification algorithm to train the model. And then after that, we're going to make some modifications. Yeah. Play around with the machine learning model to see whether we get the better result or not. Yeah. Okay. So go to the resource. After that, launch the studio. Okay. Yes. Now we go to the compute instance first to create the compute instance. Okay. Use the lowest level. The name, you have to key in the name. Yeah. Ryan uh, com I. Yeah. Compute instance. Then review create. Yeah. Okay. Create. Then after that, auto show shutdown enable. Okay. Then yes, the rest is just use the default. Okay. Creating now. Yeah. Then we go to the data. Okay. Now we're going to upload the data. Okay. So we're going to use the instructions in the LMS. Yeah. So create the data set. After that, yeah, so the name of the data set, we give the name as the student performance. Okay, and then in the description, just use the same student performance. Okay, the type is tabular, the table. Yeah, then next, yeah, from the local storage, and then next, then we keep the default storage space. Then after that, we're going to upload file or folder. You upload the file, and then from this you go to download folder, this one. Okay, then here student performance vector. Yeah. Sorry, I choose the wrong button. Download, then after that this. Okay, open. Okay, yep, so not big, so very fast. Yeah. Next. Okay, we do not change anything in the encoding UTF-8. Yeah. So Cash inform me regarding the, if you any of you advancing to the milestone 4, then you need to change to the different encoding, yeah, ISO 885, yeah? But this table is a UTF. But for the assignment 4, milestone 4, yeah, cares inform me, then I have to change the encoding, yeah. I have not tested, yeah, but thanks guys for the heads up, yeah. So any of one of you do it already do start the milestone 4. If you have a problem, yeah, then maybe you want to try to change the data encoding to the this ISO, yeah, this one 88591, but this one is tabular. Okay, next. Yep, so we don't change anything, right? Click next, after that create, yeah. Okay, while waiting this to be uploaded, we look at the computer instance, and okay, then eh just now we already create that. Okay, then just close this one. Yeah, okay, so here we go, still creating, never mind, yeah, just leave it. Go to the designer, we're going to create the pipeline. Okay, so in the pipeline we track this student performance data. Okay, after that we change the title of the pipeline to be learning disabilities prediction. Okay, click save it. Okay, now we look at the statistical data of this. Just now I want to mention to you how many student has the learning disability from the students performance data. Yeah, so preview the data. Okay, expand. Yeah, okay, look at the learning disability, this one. Yeah, so yes and no converted into the true and false. Yeah, okay, automatically. Yeah, so you look at this data, and then after that okay, we don't have the important. Okay, so from the profile, yeah, okay, this is the profile. So learning disability, where is the learning disability? Oh, this one is the numeric data, yeah. Okay, so yep, this one is the, okay, we don't have it. Number of column 22, 10,000 profile. Yes, that's correct. Preview physical peer. Okay, one moment. Why I didn't see hours study, extracurricular, sleep hours, teacher quality, school type, peer influence. Okay, here you go. Yeah, so yeah, correct. Yeah, you see that about the 80%, yeah, is the they don't have learning disability or normal, yeah, normal. This one has the learning disability. So learning disability meaning that you have a problem in learning, so very difficult, yeah. So need help, need assistance, like need the tutor or need the quiet environment, yeah, need the yeah. So basically some, for normal people like us maybe, then we can learn anytime anywhere, yeah. But some of you maybe like me, for example, could not learn when there are some noisy voice, yeah. Okay, so we want to predict, and it's not balanced, yeah. So this is about the 7,600 in the 2000. This is about the 2000. So the comparisons about the 24%, and this is 76%. This is 3 times. Yeah. Okay, so understand this is important. Yeah. Okay, close. Yeah. Then after that, we start building our pipeline. Okay, first is clean, yeah, clean missing data. So I'll do according to the lab guidelines, 100%. Yeah. Later after we finish, then if we want to play around, then we change some, we tune up. Yeah, we tweak some of the setting. But at this moment, I just follow everything according to the lab or the milestone guide. Yeah. Okay. Set the column to clean and configure cleaning options. Okay. The standard is to edit all column, which may not be the best option, but we do it first. Yeah. Then remove entire row. Yeah. Okay. Click save and then close. Yeah. After that, normalize the data using the z-score. Okay. So here you go. Then after that, connect here. So double click, then use the z-score. Yeah. Then after that, set the transformation method is to z-score. After that, include the numeric column. Okay. This is the numeric column that you want to include. Edit the column. After that, in the column name, you use the lightning copy, yeah, from the clipboard. Okay. Yeah, click OK. Yep, enter. Okay, good. Yeah, all looks like good. Yeah, no typo. Click save. Okay, after that, you continue save, close, then edit the metadata. Okay, in the edit metadata, you're going to include the column parental involvement until the peer influence. Okay, so here type using the clipboard. Yeah. Okay. Yeah, so looks like everything okay. No extra space like milestone one. Save it. Yeah. Okay, then after that, configure the categorical to be categorical, and then after that, unchanged. Yes, correct. Yeah. After that, convert to indicator. So for the categorical, we're going to convert to the indicator. Okay, a bit difficult if to close. Okay, convert to indicator value. Okay, so the column including the parental involvement and so on. Okay, I just copy to avoid the typo mistake. Okay, edit the column, then after that using the lightning text here, then type text, clipboard text. Okay, here you go. Okay, yep, so save it. Now done already. Yeah. Okay, after that, override. Yes, override. So override the categorical column directly with this. So we don't create a new column, but override. Okay, then save. After that, close. So now the data is ready. Yeah. If you want to run first, you can run to check if there is any error. Yeah. But we can split the data. Okay, split the data. Here you go. Okay, then after that, like this. Yeah. So now we are going to use the two algorithm, and then in the split we use the 70% and start the field with the learning disability. Okay, then true, and then this is true. Okay, then the edit column is the learning disability. I will ask you in the presentation what is the purpose of this. Learning disabilities. Okay, capital D. Learning disabilities. Okay, so enter. Learning disabilities. Yeah, make sure that no typo mistake. So what is this? Yeah, the explanation like this. For example, okay, I have one group of people. For example, in the school. Yeah, so I have the student in the school. For example, this is the accounting class. Yeah. Okay, so we have the 100 students. Okay, then after that, this one is the, for example, engineering. Okay, we have the 100. Yeah. Okay, so we're going to take school representations from this two class. The number of the students are 10 like this. Okay, so we need to take the students randomly. Yeah, randomly. Yeah. But here in the accounting, yeah, we have the 50 students female, and then 50 students male, like this. Yeah. And then here in the engineering, 90 students is male, and then 10 students is female. Yeah. Okay. So for example, we want to take the 10 representation from this class. Yeah. So when I do the random, yeah, then we get the 10 students. So the 10 students can be 5 female, 5 male, and then 3 female, 7 male. Yeah, because random. Yeah, random. So we not guarantee that the female and male are 5 and 5. Yeah, the same thing with this. Yeah, but it is very common that when you take the 10 students from this, then what happens is all 10 are male. Yeah, because the female is only 10. Okay, so that's a pure random. So the pure random, we cannot expect the distribution of this. Yeah, but if you put a stratified, stratified, yeah. So stratified meaning you want to maintain this proportion. Yeah. So I put a stratified on the gender. Yeah. Okay. So this will make sure that from this 10 you will get 1. Yeah. And then from this 90 you will get 9, like that. Yeah. So we maintain this composition. Yeah. The proportion of this. Yeah. Because if you took randomly, then there is a one chance that from the 100 student, then you got all the 10 female. Yeah. So we don't want that to happen. Yeah. That's normally important when the data is imbalanced. Yeah. So just now you have the learning disability. Yeah. Learning disability. The yes is about 25%. Yeah. 24%. And then learning disability no, yeah, is 76%. So when we split the data, then we have the train, and then after that the test. We want to keep this proportion. Yeah, 24 disability and 76 no, without the disability. Yeah, so we enable that. Yeah, and when we consider to enable when our data is not balanced. Yeah, so that's the purpose. Yeah, so we want the 70% and 30% also proportions. Yeah, with the original the 24 and 76% learning disability. Yeah. Okay, so that split the data. After that, you're going to add the algorithm. Okay, so we're going to drag the two class. The first is two class boosted decision tree. Okay, and then after that, two class neural network. Like this. Yeah. Okay, then after that, we use the tune model hyperparameter. Okay, or we don't add, we configure this one first. Yeah. So in the tune model hyperparameter, we configure to use the entire grid. This is better, but taking longer time. And then the metrics for the classification is based on the accuracy. You can ignore this because we do the classification. Yeah. And then after that, with learning disability as the label column. Yeah. Okay. So learning disability. This is the label that we want to predict. Yeah. Okay. Okay. Yeah. So now you click save, and then after that close. This one you can copy. Control C, Control V. Yeah. So no need to change it because it's already been configured with this one, the same setting. Yeah. Okay. So the untrained model you drag to this, and the data, the trained data set you drag to this. Okay, then you're going to add the score the model. Okay, so the sweep train data train base is given to this. Then after that, you can copy this as well. Okay. Okay, then the testing data you bring here. Okay, after that, evaluate the model. Okay, so the score data set bring to the left, and then this is right. Okay, yeah, so save it first. Is there anything we have to change? No, yeah. Looks like our experiment is completed. Then configure and submit. Create a new. The name of the experiment is AML project. Okay, then job display name is milestone2. Okay, then okay, back, go to the compute instance. After that, select the Ryan compute instance. Yeah, everything is okay. Then submit. Okay, yeah. So submit it. Then we will check if there is any error, and we go to the jobs. Okay, here, latest job. Okay, yep. So this still training. Okay, just wait for a while. Still running. Okay, so the clean missing data is completed. So the execution continue with normalized, but in the meantime we can have a look at here. in the preview the data, the clean data set. Okay, you remember that you have the 14,000 rows, yeah, but the 8,000, the last two columns are empty, so it is removed. So the rest is only have the 6,000. This was highlighted by David, yeah, if not mistaken, yeah, last week or previous lesson. This one, study physical interaction and study extracurricular. So we lost 8,000 data because this value missing. Yeah, there are also some row that some value missing, but not as many as this. So later, after we finish with the main task, you collect the screenshot. Maybe we can play around, yeah, with this. Yeah, should we keep this two column, or we replace this missing value with the mean, yeah, or with the other? Then we can uh, check, yeah, later, yeah, what the impact of this, yeah. But in the meantime, we just do follow the instruction first, yeah, follow the guide first. Okay, yeah, now still doing, and then yeah, so splitting the data, yeah, split data with dot stratified, and with stratified is different in the time, yeah, because when you split data without stratified, yeah, then it just randomly, it's faster normally. But with stratified, then you have to maintain the proportion of that, then it will take a little bit longer time. Okay, yeah, last time I put the notes milestone. Okay. Okay, so tuning the model parameter. This one is a bit long time, taking a little bit longer time. Just leave it run. Okay, yeah, so here in the split data, stratification, yeah, stratified split. Okay, so question number 6 here. In the split data, okay, the spelling is stratified split. What is the purpose of defining stratified split setting. Okay, in the split data, what is the purpose of defining the stratified split setting? Okay, yeah, that's the one question. Edit. Okay, go back to the jobs. Yep, extend the left. Okay, so looks like everything done already. Yep. Okay. Okay, so we have already this result. Then after that, the preview the evaluations result. Yeah. Okay, so let's open. Okay, now you can see this is left port and right port. Yeah. So on the left port, we have the ROC curve. The AUC is the accuracy is 0.894. Yeah, close to the 0.9, which is quite good. Yeah. This is the naive prediction 0.5. Yeah. Then this is the actual the predictions with the model with the machine learning model. Yeah. Okay, and then in the right port slightly higher. Yeah, 0.894 0.895. Yeah. Okay, and this is the confusions matrix. Yeah. Yeah, this one actual and predicted. Yeah. And then this one is the true negative is high. Yeah, 1713. Okay, so what is meaning that the Yeah, correct. Yeah, so true negative is 1713, then actual is force. Okay, let's look at the. Okay, yeah, this one is comparisons, some of the model. Yeah, so from the previous run, which one is the best is this one. Wait, cumulative AC 0.4, positive 1000 score bin. Yeah, so this is the score is from 0 to 1. The score from 0 to 0 0.1, 0 0.1 to 0 0.2, 0 0.2 to 0 0.3. Yeah, this is the detail. Yeah, and then after that the accuracy. So after that, then after you adjust the higher, then 0.95. Okay, you can play around with this. Yeah, like for example, if the okay, oh the AUC is 0.494. Yeah, which is actually considered as not very good. Yeah, because if you predict this one is better. Yeah, 0.84. Yeah, this one is not good. Yeah, because 0. What is the meaning of the AUC? AUC is the area like this. Yeah? This is ROC curve. The AUC is this, the area below this. In the normal two-class classifications, normally the score, the threshold score is 0.5. Yeah, so when you move this 0.5, yeah, then what is the AUC is 0.5. Okay, let me explain like this. For example, this is the ROC curve. Yeah. Okay, this is 1. This is the maximum. Yeah, this is the 1. Okay. Yeah. So 1 times 1 is 1. Okay, like this. Yeah. Then 1 times 1 is 1. After that, if you just make a smart guess, meaning you don't have to create a machine learning model. Yeah. Like for example, I have the one student. Then after that, you guess, is this student has a learning disability? Then I just answer no. Yeah. Okay. So my chance is 50-50, right? But if the most student like just know 24% has a disability, yes, yeah, and then after that 76% disability is no, yeah. So you can see that by guessing the no without the model, then you have the 76%, yeah. So if you create the machine learning model, then your model should have the AUC more than 0.76. Yeah, if it is less than 0.6, then it is bad, because may as well I, I don't need to create the model, just use a smart guess. Yeah. Okay, like for example yeah, so this one. Yeah. Okay, so if this 0.8 or this 0.9, that's better, greater than this. Yeah, 0.6, 0.76. Yeah. Okay, back to this. Yeah. So the AUC is 0.94. Yeah, which is not good. Yeah. And then this one is 0.8. Yeah, through the normal threshold. Yeah. So that's meaning good. Yeah. This is false positive rate. This is true positive rate. And this is the leaf curve. Yeah. Leaf curve meaning that how big or how well your model predict or give the improvement compared to the not using the model. Yeah, that's the purpose of the leaf curve. Yeah. Okay. Okay, so this chart is both are the same, but only the difference is here. Yeah, on the AUC. Okay, So you see for the left, which is the on the left is here, yeah, the two class booster decision tree. Yeah, this one is better. Yeah, this one's better. Okay, so that's according to this result. Yeah. Okay. Then now I'm going to look at the just now. Yeah, our data is very highly erased, yeah, or removed because of this clean missing data. Yeah, so I would like to experiment. Yeah, that I don't use that two column. Yeah, I don't use that two column. Okay, and then just now you remember 0.8 something. Yeah. So in the clean missing, I clone. Yeah, I make a clone for this. So I clone the experiment. Then after that, so here I okay, replace, yeah, missing value with the min. Yeah, replace missing value with min. Okay, so I save it. Yeah. So here in the clean missing data, then we change. Yeah, not remove entire row, but replace with the min. Yeah, or maybe replace with the mode. Yeah, so the those that very uh, often come out. Yeah, okay, replace with the mode. Okay, so change this with the mode. Yeah, so mode is the data that the highest frequency. Okay, so the rest is still the same. Then close. Yeah. Okay, so I configure submit. Then after that, we're going to create a new. The name is replace with the mode. Okay, yeah, replace missing value with mode. Okay, I think we cannot put the underscore. So like this. Yeah, okay. So next, after that, use the uh, next compute instance. Okay, review the submit. Then submit. Yeah. Okay, so we modify. So we want to keep those. Alternatively, you can also remove those two columns. We're going to do this in the next one. Yeah. Next, we're going to play by uh, only selecting the column that we think useful. Yeah, that's the next one. Or we can do that now. Yeah, okay. So I clone again. Yeah, and then this one we rename. Yeah, select six column. Yeah. For example, we want to make our experiment simpler by just choosing the six column. Yeah, okay. So select six column, and then after that we okay, we add the select column. Okay, so student performance. After that, yeah, we going to add one more select column. Yeah, select column. Maybe we don't need to mention the how many, but select the filter selected column. Filter selected columns. Yeah, okay, click save. Filter selected column. Then after that, yes. So in here we have the select column in the data set. Yeah. Okay, then after that you go back here. Yeah, we remove this line. Wait, one moment. Okay, remove this. Cannot remove. Okay, this one. Okay, yep. Mm, like this, yeah. So before we clean, then we already select, yeah. So only edit column, then exclude, yeah. Exclude here, exclude the column. Okay, include all column, then exclude the column. This one. Okay, the last two, yeah, the study we don't want. This one also we don't want. The study physical, the study extracurricular, yeah. And do you think the gender, yeah, it's sorry, include all column plus, yeah, exclude. Okay, column name. Okay, so here in the column name we want to exclude this study physical, then this extracurricular. Okay, what else? Let's see. Yeah, our study attendance, parental access to resources, extracurricular. Yeah, do you think the student will have the learning disability by having the extracurricular? Yeah, I don't think so. Yeah. And then the sleep hours, previous score, motivation, internet, yeah, peer influence, physical activity, learning disability. Okay, so parental education. So do you think the parent education have influence? Distant from home, yeah, maybe stress in the traveling, yeah. Okay, exam score. Okay, maybe yes. I'm not sure. Yeah. So then just remove these two. Yeah. Study physical interaction. This one. Okay. So we remove these two column. Yeah. Okay. So close. Then after that, you have this claim missing data, normalized data. Okay. So let's see if that the two are available. Yeah. Study physical and study extracurricular. We need to make sure that that column no longer appear in the this, yeah, in the edit metadata. Clean missing data. Okay, then we can remove, yeah, if you want, but replace with mode is okay. Yeah. How about this one? Normalize the data. Yeah. Okay. So look at this. Yeah. So physical just no, we don't have. Yeah. Okay. Good. After that, here in the edit metadata, okay, peer influence, distance, yeah, okay, score, don't have, yeah, okay. Then close. Okay, looks like those two columns are not in the comfort indicator value, yeah. So edit the column. Do we have the score just now? No, we don't have, yeah. Okay, so everything good, yeah. So we can also submit, yeah. But let's look at the jobs first, yeah. Okay, so in the jobs, replace with mode, yeah. Okay, so click, yep. So still ongoing. Okay, But in the meantime, you can see in the after clean missing data how many rows we have. Okay, so right click, preview the data. Okay, clean data set. Okay, so expand. Yeah, so you kept the 14,000. Yeah, the 14,000 row is kept. Okay, so we have the more data. Okay, just wait for a while until this finish. Then we're going to compare. Yeah. Okay, now is good. Yeah. Now before we discuss the or we can now open this one. Yeah. Preview the data evaluation result. Yeah. Yep. Okay. So here you go. The left port AUC is 0.729. Yeah. Okay. And then false positive rate, true positive. This is the ROC. Okay. Now it's a side by side. Yeah. Side by side. So this is a score data set. This is the right port. Yeah. Okay. So left and right. Yeah. Okay. This is the blue one on the left. This one is on the right. Yeah. Okay. 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 Yeah. So yep. And now we got the this conversion matrix 0. I use 0.71. Let's have a look on the this 0.71. Okay. Okay. So left port. Yeah. This one is 0.729. So yeah, actually not different much, yeah, compared to the previous one. If you compare to the previous one, let's open the jobs again. Then after that, sorry, the jobs, yeah. Then after that, we open the AML project. This one, yeah, okay. Yep, preview the data. Okay, yeah. So okay, this is the score data set on the left, yeah, the blue one. This is on the right, yeah. This one's very bad, yeah. Okay, not good, yeah. Okay, yep. So this one is better, AUC. Okay, so maybe we compare one more. Hopefully we still have time. Let's use the time to, we still have 60 minutes. Okay, yeah, the last filter selected column. Yeah, okay, so run, then create new filter selected column. Yeah, selected columns. Then okay, submit. Yeah, okay. Hopefully we still have time. Okay, let's go to the jobs. Then after that, the monitor. Uh, hmm, have we run that? Have we submitted? One moment. Ah, okay. Filter selected column. Yeah. Okay. Yep. So still running. Okay. We stop the record. We wait for a while. Okay, everyone. Time is ticking. Then we only have 8 minutes left, but still ongoing. Hopefully, can finish before the lab expired. Okay, the longest part, the tuning model parameter already completed. Now is continue with the scoring the model. Okay, time is ticking. 6 minutes left. Yeah, hopefully we going to have enough time to complete this. Okay. Yes. So I think we can finish in less than 5 minutes. Okay. Wow. Going to expire soon. Okay. Wait a while. Yep. Okay, done. Yeah, so we quickly have a look on here. 3 minutes left. Yeah, okay. Let's see. Ah, okay. So this one is this better. Yeah, the blue one still better. The boosted decision tree. This is the neural network on the left. Yeah. Okay. So AUC is 0.725. So seems that the boosted decision tree perform better. And then the the more data, yeah, does not shown giving you a better AUC. Okay, but the accuracy also drop, yeah, here 0.6. Okay, and this one, the first one, yeah, which was this one, yeah, looks like this one is better. Okay, oops, sorry, preview the data. Okay, yeah, the neural network is very bad, yeah, on it, but this one is the on the left, yeah, the blue color, the boosted dictionary is doing very well. This one is just like a normal uh, guessing, yeah, 0.4, yeah, this one, the right port, yeah. So the left port is better. Okay. Yep. So that's the explanations, and after this we can take the screenshot, then take a break.